Hello, Bailey. Thank you for your question. Now, I understand. I'm sorry that we had a delay here, but due to the upgrade in the operating system, Jing no longer works for me. So I had to do some workarounds. And the workarounds that I'm doing right now is I'm putting this up on YouTube for the present, for the time being. So let's go ahead and take a look at what we're looking at. Now, for this particular problem, you were asked to go ahead and find and read the problem, turn it into a matrix problem, and solve the matrix problem. I've got the view and example up so you can see it. If you read the language, it says that if you get it as the particular percentage of the 2 million after all of the other bonuses have been subtracted. And so that gives you these four equations just as basics, each of which can turn into a basic linear equation in standard form. x1 to the minus x2, that's going to be plus 0.0397x2 plus 0.0397x3 plus 0.0397x4, all on the left-hand side, x1 plus 0.0397x2 plus 0.0397x3, etc., equal, on the right-hand side, the 0.0397 times 2 million. That's where the 79,400 is coming from. You can actually see this, right? 0.0397 times 2 million. 79,400. That's where those numbers are coming from. And once you've actually done that, you're going to get the matrix set up. Now, let's go back to our problem, and we'll figure out what we need to do here. The idea is fairly straightforward, though. You have this matrix A that you need to multiply by this X matrix to come up with the constant matrix. But you want to solve for this. And so we need to hit this with the inverse on both sides, and that'll give us the value x1, 2, 3, 4 is equal to the inverse of this matrix times that. Now, I did debate for myself a little bit right there whether I wanted to actually do this one by hand. To find the inverse of this by hand, yeah, it's 16 3x3 minors that you'd have to calculate for these. And that's probably too much. So we're going to use Wolfram Alpha to do the job for us, okay? Not going to do it with this. Let's go ahead and run this through with the actual numbers here. Now on this number right here, first I wanted to show you how you can enter the matrix. Here's the matrix that we're going to need to solve this problem, 4.19 and all that. So once I've done this, I'm seeing 1 times 0.0419, and there's the matrix we need, right? How do you enter this? Well, you enter a matrix into Wolfram Alpha with curly braces and uncurly braces. You start the matrix with a curly, start the row, first row, with a curly, and then enter the numbers with commas. Uncurly to end the row, comma, curly to start the next row. And so it's curly, curly, number, comma, number, comma, number, comma, number, uncurly, comma, curly, number, 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 separate with commas, uncurly, comma, curly for the third row, and the same for the fourth row. And then when you're finished with the fourth row, you'll finish the fourth row with an uncurly, and then another uncurly to end the matrix. So it's curly, curly, number, comma, number, comma, number, comma, number, uncurly, comma, curly, number, 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 uncurly, comma, curly, number, 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 and then finally uncurly, uncurly to end the matrix. And when you plug that in, Wolfram Alpha will recognize this as the matrix, and it will display it for you. It'll give you some information on it too if you're ever interested. But now, what we want is the inverse of this matrix times that constant matrix that we have on the side here. And the constant matrix here is going to be 4.19% of 2 million, 3.40% times 2 million, on like that, right? First, we need the inverse matrix. So let's go over here and take a look at what the inverse matrix is going to have to be. To get the inverse matrix to calculate in Wolfram Alpha, you just write the word inverse in front of it. That's all it takes to it. Now you notice that I started this with a parenthesis. That's not necessary to calculate the matrix, and I ended with a parenthesis as well. That's not necessary to calculate the inverse, but it is going to be necessary if we're going to get multiplication by the inverse to work properly. Because what I'm going to do is I'm going to take this times, with a period for times on matrix multiplication, uncurly, curly, curly, and then that constant column that we're going to work off on the other side. But as it is, if we ask for the inverse, it will calculate it after I just say inverse next to the matrix, and there's the inverse. Now, the next job right there is to actually multiply this by that constant matrix, where each of these numbers is the amount of 2 million that we came up with. For example, you'd have 0.042 million, 23, 123, times 0.419. And that's going to be the 83,800, right? And for the 34%, right, 0.034, 034, that's going to give the 68,000, etc., like this. And so there's the matrix we want to do right there. But the way you handle this is you finish the inverse matrix, right? There was the end of the parenthesis around inverse, right? See that? And now we're going to multiply this by this matrix here. And now notice that when I multiply, I use the period, and then each of these is a single entry row. So it's curly, curly, the number, uncurly, comma, curly, the number, uncurly, comma, the number for the third row, and then for the fourth as well. When I multiply that out, what do I see? Well, I'll get inverse matrix times that constant matrix. So we've taken from going on from AX equals B to finding X, there's the X, the result, as the inverse of A times B. Now here are the four numbers that we come up with to the nearest dime or whatever. And but the actual problem that you're asked right here was to round to the nearest thousand as needed. So we'll take these numbers as 77, 62, 54, and 45, and enter those numbers. 77,000 to the nearest thousand, right? 62,000, 62,000. What was it? 54,000 and 45. 54,000 and 45,000. And that should take care of this. You can let me know if you have other questions, and I'll talk to you soon. Take care. Now I need to figure out how to end the recording too. There it is. Stop recording.